Hi everyone, my name is Jake Anderson. I am the current student director for MSAT as well as the chief engineer for the Mr. and Mrs. SAT mission. Today I will be covering some basics on working in GitLab and proper ways to maintain and operate in GitLab. So what is GitLab? So as a refresher, it is used to store, manage, and document the team's software. So this includes microcontroller code, flight computer code, you can even find code, like testing code, for example, MATLAB and LabVIEW files. Though this is not always the case, you'll most likely find some code, whether it's MATLAB and even C++ files in Google Drive. This is not recommended, and those you finding those in there is bad practice of previous members. Um, so my recommendation moving forward is if you're working with any kind of code, even if it's MATLAB or some basic level code, even like with STK. I recommend just throwing all of it in GitLab because there's tons of benefits to storing it in GitLab and awesome ways to manage it. So what you're looking at here is the MSAT homepage in GitLab. What you're kind of looking at is your standard file sharing with folders, and then we have repositories. Where repositories is a dedicated folder for a specific project. And then folders store more folders or more repos or repositories. So for example, if I come over here to NS8, um, the folder is NS8, and then within it we have repos. So you have a repo for Mr. CDH, the ground station, Pluto code, Mrs. Sats code, SI algorithm, and so forth. So within each repo, there's different ways to organize it and what's called Git workflows. So here in Mr. CDH, we have the master branch. Every repo will have a master branch. And within the repo, outside of the master branches, you'll have a lot of sub branches, not even sub branches, but separate branches other than the master. The master holds the most up to date and correct code. When you're working on within a repo, you always want to make a new branch from the master so that when you are testing things, trying to implement new things in the code, and you accidentally break something, you're not breaking something that everyone else is using. You only broke your own code. Let's say you got to the point where the code is, you just can't fix it. You can delete that branch, or what's also called rebase, which is essentially pulling the master back again and re-updating your branch to fix it. In here, we have something called the develop branch, if I can find it. So develop is just another branch to kind of help maintain your repo. So I'm going to come over here to this tab and kind of break down some common workflows. If you want to pull this up on your own, I'm going to Control C, copy and paste it into my window. So I'm going to cheat. But all you got to do is pop this into your window and search it, and it's going to be the first one that comes up. So there's no correct workflow, but there's a lot of common workflows that are very useful and successful. So if you're starting a new repo, I'd recommend going off some workflow that has already been done before. Don't try and create something new. Right, so your most basic workflow is where there's only one master branch. You really don't want to do this unless you're working on a branch by yourself, where you know what's going on the whole time, and you don't have anyone else working in. Because if you have someone else working in and they push something to master, then it gets tricky because you don't know exactly what they did. And if you're working on something separate than they did, then you two can kind of collide and cause each other pain. So if there's more than one person working in the repo, the most common one is just your Git feature branch workflow. We have a master, and then for each feature you want to add, you have a separate branch. Right, so we come back over here, ignoring develop, we have master branch, and then whole bunch of different branches for example, software, PDM, digital interface. You can name the branch your own name. Um, Generally, name it what you're working on. That's a better workflow per se, because I don't know what. This is the bad example. Me, I created this, and this was more for example previously, but I don't know what Jake was working on. I don't know what Austin was working on. I don't know who that is, right? But if I come over here, oh, they're working on the digital rewrite or the pressure transducer fix. So then if you were to pick up, or I guess someone were to pick up your project, it's much easier to find, and they don't have to go look for your name or, see or find what you were working on. What we use is adding that develop branch. So you kind of think of that as a version 1.2, 1.3, where your master branch is the big versions 1.0, 2.0, 3.0. This is beneficial when you have a big project with many things going on, because then you always have a master branch that will always work no matter what. And if you were to add a feature to the develop branch, and that were to break the develop branch, that's okay. Someone can still grab the master branch and create their own project or create their own branch and add their own feature. Where if you don't have this, then you can try and add a feature to the master. And if something were to break, then you have to fix that immediately. And that can cause pain for other people if they need the fixed master branch immediately. So like I said, this is more common in big projects. We use this in Mr. CDH because it is a relatively big project, but for most cases, default to the Git feature branch workflow, just with one master and a branch for each feature. If you think you need a develop branch, go ahead and do it. It doesn't hurt, but it does add a little bit more work to maintain it properly. There's a couple other workflows down here, 4 and 5, that I'm not going to get into. This is kind of what they do more in the industry with much bigger programs like, honestly, MATLAB or other big software companies will use a much more complicated workflow because they have a lot more things going on than we do. So there's a little brief overview of workflows. So some of this should be review for you. If you have not gone through the Git training yet, let me come back to that. Go through the Git training first. You can do this by yourself. There is a video for it. Be eventually posted to our YouTube page, but you can also find it in the drive. It walks you through this, but you also don't need the video. There's really great instructions in here on how to get everything set up. So what I'm going to do is just open up Git Bash, which you will already have installed if you go through this Git training. Additionally, you will also need your SSH key setup, which is done in here. So to open up Git Bash, your common commands. Again, this is all covered in the training, so I'm not going to go through it too much right now. And then let's see where I want to go. I want to go. Okay, and all I'm doing right now is I'm going to clone a branch for an example. So we're going to come back over to MSAT. Today I'm going to be working out of an SA ground station Pluto repo. And then to clone, I'm going to clone with SSH. Again, you will need your SSH key set up. So if this doesn't work immediately, it's most likely because you don't have your SSH key set up. And then we can see that right there. You can ignore these files for right now. We're going to do stuff with them later. All right. Well, lots of emails right now. All right. So I am now in the repo. So I've successfully cloned it and in the repo. So this, from here on out, this wasn't really covered in the Git training. So once you do the Git training, feel free to skip to here to catch back up. So the big thing that you guys need to know right now, or at this point, is the difference between a global and a local branch. So right now, what I'm seeing is all my local stuff. So if I go get branches or branch, so there's only one branch and it's main or master. Um, so I guess so main and master are the same thing, they're used interchangeably. So you have a local branch and a global branch. Really, what are those? So your global branch is what we see here, right? This is the global main branch. Um, your local is what is on your local computer, right? So if I were to change main or change some branch, it would not change globally unless you push those changes. And the same thing here, if someone were to create a new branch, change main, change whatever, and push it to the global setting, you would not see those changes unless you pulled those changes from global or the cloud, however you want to think of it. So right now I'm just going to do git checkout. I'm going to check out this branch and kind of run through an example real quick. So I'm going to open this up real quick and just come over here to the folder. So I'm going to make a couple subfolders here. So we'll say files. And then I'm going to throw all of these in files. And then now if I come over here, again, I'm seeing the same thing in these two windows, right? So as a refresher, this tells you where you're located, right? So MSAT, GitLab, NSA, whatever. So if I come back, so here, if I click ls, we have README and files, which is what we see here. And if I go into files and do ls again, then now you see all these files, right? However, if I go to over here, I don't see that, right? And that's because locally you've changed the repo, but not globally. So what you need to do is, so one thing you can do is git status. Will tell you what changes have been made compared to the global or compared to origin. Again, there's multiple terms for global or origin. It can get confusing, but it's one of those things you just gotta learn all the terminology. So if I do git add, this adds everything. Yeah, that's all right. So you can ignore those warnings. So if I do git status now, then you can see all these files have been added, where previously they were not added or committed. Well, actually, at this point, they're not committed either. So this tells you what files have been changed, if any. So now I want to commit these files and then push it to global. So committing means you're saving these changes on your local branch. So come here, git commit -m allows you to enter a comment. Always enter a comment when you do a commit, even if it's something like updating things or put some kind of message so that, and really be more descriptive if you can, so that when people in the global GitLab see your commit, they can see what you did or have a brief understanding of what you did. So I'm going to do say added files, right? That's all I did. Eventually, if you're actually changing things and doing complex things, have a better comment. Don't make it really long, just a sentence or two on what was done. So now if I do git status, it's up to date. So git status, again, just tells you what changes have been made compared to your local branch. So when you do git commit, you're saving those changes, right? And then now I do git status, there's no changes seen because what you committed was just saved. And so git status is referencing what is saved now. Um, so now we want to push this to global, because still at this point I can refresh this and nothing's there, right? We don't see anything, or we don't see those files we added until we push them to global. So all you gotta do is git push, and you'll see uh, everything all good. And now when I refresh this, the files are there with txt and all that. So hopefully that kind of helps you understand the difference between local and global. Now, if someone were to change global, you would have to pull. So right now there's no changes that I'll be able to pull, but I can still do git pull. I want to do origin. Again, origin is mass, or is the global, and origin is everything globally. So I can do origin and pick a branch, right? I can do the grants files, or I can do main or whatever, but I just want to pull, let's say I just want to pull everything, just in case there's new branches or anything like that. Click enter. Now I'm already up to date, so I can't pull anything because I'm already up to date. But if someone made a new branch or updated a or pushed is the correct terminology, pushed to another branch, and I was going to use that branch, then I'd have to pull that and get the updated branch. All right, now, so let's go into some workflow on how to maintain things in GitLab. So issues is going to be a very useful resource that, again, I highly recommend. So I already have one here called an add grants files. And I'm going to edit this real quick and just say organize, if I can type, organize grants files, since I have yet to do that. So let's say I want to make a new issue, right? So I know one issue that I'm missing here, and that's so we need to implement Doppler shifting for our ground station. So you can pick the issue, or I guess the type. This is an issue because it's something we want to add. If there was a bug found or something, then we want to make that incident. All right. So for a description, describe the issue or what needs to be done as clear as possible. This will save you time in the future, so that if someone else comes and addresses this issue, they know exactly what needs to be done. You can do a lot of fancy things in here. You can link things, feel free to play around with the description. Right now, I'm just going to leave it blank, and I'll come back to it. So you can assign this to people. So you just type in their username. So if I type in mine, I can assign myself. Right now, I'm going to leave it unassigned. So due date, if you want, milestone, that is commonly used for, again, kind of the versions I was talking about. So if you're working on 1.1, you can add that milestone and such. And then labels. Labels are also very useful. Right now I'm going to do backlog because no one's working on this, but eventually I'll put a low, high priority, medium priority if it's in progress or if it's done. But for right now, I'm just going to do backlog, and I'm going to create this issue. So now the issue is created. You can add comments to it. One thing you always want to do is create the branch. So I like the generic, or I guess you could say default naming scheme. So this is issue number 2. So if we come back here to issues, this is 1, this is 2. And we create the branch, it defaults to the issue number and then the title. So I'm going to go ahead and create the branch. I don't want to create a merge request yet. And I'll kind of cover what that is here soon. And generally, clone it from main. So the source means I'm going to create a new branch. Where am I copying it from? So I can copy it from, Phil will let me. I can copy it from grants files, if I can remember the name. Yeah, oh, there we go. So I can copy it from this if I want a certain feature that isn't approved yet. or a certain branch that hasn't approved or been merged into master. But generally, just do it off main or master, wherever it's called for you. So I'm going to come here and create the branch. And now the branch is here. And then here's a great example of creating a branch but not happening locally. So again, we're back here at the local scheme of things. I want to check out this branch, right? So we'll do git checkout. You can click 2 and then tab. So, but git locally there isn't a branch named that. So if I do 1 and tab, right, git knows, hey, there's a branch called this. So even if I were to type out the whole thing, which let's see if there's a way to cheat that. There's not. So I'll just type this whole thing out. So implement Doppler shifting. Hopefully I've typed that right. But even if I typed it right, there's no files, but really there's no branches named that. And that's because the global has been updated, but the local has not. So again, all we need to do is come here, git, pull origin, and then you can see here, new branch named, to implement Doppler shifting. So now, if I come here, I can check that out. And you can see I am now in that branch. So there's just another example of global versus local. And commonly, when you first get on for the day, go ahead and pull origin, just in case, just for whatever reason. It just helps to make sure your local Git is constantly, or your local repo really, is always up to date. Again, it's just good practices. So now, what I do want to do real quick, I will organize grants folders. So real quick, again, these two should match each other, right? So let's, I think because I was in the folder, I kind of broke it a little bit. So we'll try this, git checkout main. So if I come here now, okay, I didn't remove the this folder for some reason. But you saw how that folder was empty, right? That's because we are in a different branch. And I deleted the folder. So, but now if we could go back, git, and really we can do git switch to, I think maybe that's the command. All right, well, either way, git checkout. Oh, it's not liking me right now. Either way, git checkout grants files. Oh, wait. It's because, so here we go. We were still in this location, so it's forcing the folder to stay open and breaking things pretty much. So let's leave this and then come back into here. And then now let's try to git switch. Git switch. There we go. Enter. So right here, and then now you see over here it popped back up. All the files are here. So let's try this again. So git switch main. And yeah, there you go. See, it's gone. So we just kind of broke things a little bit by staying in that folder. So what I want to do real quick, I'm just going to come over here and organize these. So name this functions, and I have another one named examples, TLEs, and kind of organize this a little bit. ground station, modulate, here we go. And all those will go in functions, and then this will go in functions. Nothing's in there, okay. And custom packet, ground station, and these will go in examples. And that's just a picture. All right, so we somewhat organized it there, right? So now, come back here, get status. You'll see now untracked means we created something new. So we created new folders, and then it thinks we deleted these, but we really just changed the location into these folders. So if I just do git add all, and then get status, right, so it renamed it to a different file or folder location. So everything's good. So I want to do git commit -m organized files, and then git push, because I want to push it to global. And if you come back over here at grants files, we will now see it is all sorted nice and well. So now let's do a merge request. So grants files branch, so the issue per se. So come back over here. We did what we wanted to. We wanted to add grants files and then also organize them. So you can create a merge request, but don't do it here because it creates a branch and gets just weird over here. But so we want to come to merge request, and we're going to create a merge request. And then it says resolve. It doesn't really matter what the title is, but I like saying merge, and then the actual branch name. If you put draft, so it says draft. If you put draft, all that does is prevents it from being merged until you remove that from the title. So even after you create this merge request, you can edit the title and edit things. So for some reason you want to make a merge request, but you want to block it. There's certain scenarios where you want to do that, but commonly don't. If you want to block it for some reason until maybe you're waiting for another MR being merge request. If you're waiting for another MR to be merged before you merge yours, then draft is a good way to prevent it. So yeah, we're gonna merge this. Closes number 1, so you'll see number 1 is the issue number. So if you come back over here, number 1, right? So what this does is it links that when we create this. Assignee, I'm gonna assign this to myself. Reviewer, I'm gonna assign this to myself. Hopefully I only need one reviewer. Sometimes you need more. And we're gonna put this in progress. So delete source branch. Once you merge it, there's no reason to have the old branch. So unless, again, and there's no right or wrong way to do this. It's what you want to do. I commonly delete the source branch because then you kind of have 2 duplicated branches at one point. And then the master eventually changes and then you're just left with this old branch, and it just sits there until you manually delete it. So I just delete it when it's merged, and then squash commits. So here we only have 2 commits, so I don't need to do that. But if this is a big feature and you have like 200 commits, you don't want to transfer all those commits into the master branch. It just gets things messy. So again, generally squash all the commits. So there's just 1 commit for the MR rather than 2 or possibly 100, So we're going to go ahead and create that. Ignore the pipeline message. So here, a couple things going on here. So here's the overview. I can make comments here, and then I can make a thread where this can't be, well, you can merge it before the threads are resolved, but this is a good way to track, hey, there's something wrong here when you have people reviewing it. So you can set multiple reviewers and multiple assignees. Generally, assignees are the ones who worked on the issue, and then the reviewers would be other members. Again, generally the CE, the lead, someone who can properly review it. So here's when they can put comments or be like, hey, you forgot this constant is wrong, or they can make comments here. And then resolved. So I can come here and click resolved, and then notice how there's one unresolved thread, and then I add comment, and then all threads resolved, and then there also be a little comment down here saying I resolved all threads. So this is a good way to kind of track discussions and whatnot. Again, commits just shows all the commits that have been made, and then changes. From a reviewer's standpoint, this is a great way to see what happened, right? So this compares your, I guess, your merge branch and what you're trying to merge it into. I guess so. This would be called the source branch. This would be called the target branch. So this helps show the changes between the source and target branch. Sometimes if you have really big files, they won't show unless you click expand. But I'm gonna do that. So yeah, here you can it goes through all the files. You can kind of close these and make it look cleaner, right? So you can see all these, what was changed. Again, here things were only added. Where eventually, if you're actually working on things, or I guess changing things, you'll see minus something in red, meaning you deleted something, and then the green is you added something. Another cool thing, so I can just say, come here. I can make a comment and say, wrong string, or really, and this is a good example, not a string hex. So I can add the comment, but I can also insert a suggestion, and I can come here and say, hey, you should name this custom hex, because that's a hex value, not a string. Well, really, in MATLAB it's a string, but if you know, not data types. Either way, this is a hex value, right, in form of a string. So this is just an example, right? So add comment now, and then you can see it over here, but if you come back over here to overview, you can see that, and then the assignees can just apply that. It makes it easy. So I'll just put applied suggestion, but I'm not going to do this because I'm sure this is used in other places. So if I did that, it would break a whole bunch of things. So I'm going to put doesn't matter and then resolve it. And then all threads are resolved. And then let's go ahead into just actually merging it. So still add commit message. And then I'm just gonna make this commit message from what the target branch or main will see. So let's approve this. And then let's merge this. All right, so now let's come back over here to the main. And then main, you can see we merged that branch into this one. And hey, look, the files are here, right? Everything's here. All the changes we made are here. And then if we, let's see, we can go to commits. And then we can see all the commits that we did. So, and this, you can do this for any branch. So over here, it just shows the commits. So now when you clone a branch, right? So we cloned this branch from main, it carries all the commits over. An email notification. So these commits were from the main branch, which we can see right here, right? And these are the commits we just added now. So it actually carried over 2 commits because I forgot to delete one of them. But these 2 commits are just from the merge request, right? So you can see the commits, and then after a while, you'll end up having a lot. So for example, Mr. CDH, we're in master, so if we go to develop, there's going to be a lot more commits. Let's just type it. Develop. Actually, just come over here, commits, develop, and you can see there's a whole bunch. So this isn't that many. Most likely because they squashed all the commits when they were working on it, right? They just merged. Their commit was they merged a branch into whatever. However, if they kept the commits, I mean, didn't squash them during the merge review, we probably have a lot more here. And again, there's no right or wrong way to do this. There's just ways, and however you want to use your workflow is up to you. And so we'll just do this one last example. So if we switch to main, git switch main, ls, the readme is the only one there. If we come over here, right, the readme is only here. Again, that is because we need to pull origin because we made that merge request on the global repo, not our local repo. So all we gotta do is git pull origin. You can see, hey, let's see, origin main was changed with these changes. And if you go through, it will make sense. Now, ls, you have files there, and then I'm just gonna pop over here, and you have all the changes in your main now. So there you go. That kind of wraps it up. So yeah, thanks for watching.